Example 4. In this example, we're going to apply the idea of splitting forces into components to some problems in context. So here we have a diagram showing a box of mass 12 kilograms being pulled along the ground by a rope inclined 40 degrees to the horizontal. The box accelerates at 0.2 meters per second squared and the tension in the rope is 70 newtons. First of all, we're going to calculate the force resisting the motion of the box. As we already have a diagram, it makes sense to annotate this rather than starting from scratch. So let's add our forces onto our diagram. We've already got the 70 Newton force here. We know the box has a mass of 12 kilograms, so the box will have a weight of 12g. The box rests on a horizontal surface, which means we have a normal reaction force acting upwards. We'll call that force R. We're told in the question there is a force resisting the motion of the box. The box is moving to the right, which means we should have a force going to the left. It doesn't really matter what letter we'll use, but I'll use F. In part A, as we're trying to find F, it makes sense to resolve horizontally, and as it's accelerating to the right, we will choose right as the positive direction. We have a component of the 70 Newton force. As we're crossing the angle, we'll use cos, so 70 cos 40. F is resisting motion, so minus F. And that will equal mass times acceleration, 12 times 0.2. If we add F to both sides, then we'll have positive F on the right hand side, and we'll also subtract 12 times 0.2 from both sides. And if we put that into our calculator, we get 51.223. But since in this question it's telling us that we're supposed to use G to two significant figures, that's telling us we should round the answer to two significant figures as well. So that will give us 51 newtons to two significant figures. In part B, we need to find the normal reaction force acting on the box. This time we'll resolve vertically. We'll take upwards to be the positive direction. So we've got R acting upwards. We've also got a component of the 70 Newton force acting upwards. As we're not crossing the angle, we'll use sine. So R plus 70 sine 40. We've got 12g working downwards, so minus 12g. And the box is not accelerating in the vertical direction, so this equals 0. Rearranging, we get R equals 12g minus 70 sine 40. And if we pop that into our calculator, we get 73 newtons if we round to two significant figures. Right, here's another problem then. Pause the video, have a go at it, and then check your solution against mine. Welcome back, I'll go through my solution then. So first of all, we're told to use G as 9.8 meters per second squared. That tells us as well to round our final answers to two significant figures. In the diagram, we've got a car of mass 3 kilograms being pushed with a force of 8 newtons at an angle of 15 degrees. The force is already on the diagram, but the mass of 3 kilograms isn't yet. We're also told motion is resisted by a force of 2 newtons. That's not on the diagram either. So let's start by adding some forces to our diagram. We've got a weight acting downwards of 3g. We have a normal reaction force acting upwards. We'll call that R. And we have a force resisting motion of 2 newtons. Motion here is to the right, so that will be a force to the left. It doesn't really matter that much for the purposes of this diagram, but I really don't like forces going into the particle. So what I would prefer to have is this 8 Newton force here projecting outwards at an angle of 15 degrees. Now that we have all the forces on our diagram, let's resolve horizontally. We've got a component of the 8 Newton force to the right, that's 8 cos 15. We've got a resistance force of 2 newtons. And mass times acceleration is 3a. From here we can put this into our calculator and then divide by 3, which gives us 1.9 to 2 significant figures. For part B, we'll resolve vertically. We've got R acting upwards. We've got 3G acting downwards. And we also have a component of the 8 Newton force. We're not using the angle, so we'll be using sine. And there's no acceleration vertically, so that equals 0. Rearranging this gives us R equals 3G plus 8 sine 15. Which gives us 31 newtons to 2 significant figures.